Hello, online ag economics students. Miss Pierce here, and today we're going to talk through some of the concepts in Chapter 4. Chapter 3 was about budget constraints and marginal utility, and we're going to kind of put those two concepts together to look at consumer equilibrium and market demand. I'm not going to read through all of these objectives because a lot of it is not going to make any sense until the end of the chapter, so maybe we'll revisit these at the end of the chapter to summarize what you learned. So we're going to start by defining consumer equilibrium. So consumer equilibrium is achieved when satisfaction of a consumer is achieved by purchasing a specific combination of products that stays within the consumer's budget. So two things have to be met with this. Not only do we have to be staying in the budget, but we have to find that specific combination where satisfaction is maximized. So this is going to be dependent on the price of item A, the price of item B, and the income that a consumer has. So if we look at a graph to try to identify consumer equilibrium, in this graph we have multiple levels of utility. As you can see along the right hand side, if you remember from previous chapters, the levels of utility increase as we move to the upper right hand corner of the graph. Okay, so if we look at a lot of these points, let's ignore the blue lines right away, but if we look at some of these points, we can see that point B would provide the most satisfaction for the customer or the consumer. Point D would provide the second most because it's located on this second curve here. Point A provides just as much satisfaction as point D because it's along the same utility curve here. And C would provide the least amount of satisfaction because it is lower and to the left. It's the lowest and most leftmost point on this graph. So we have our budget line in blue here. We have it in dark blue. I'll kind of mark it in light blue. That's our budget line. So the consumer cannot spend anything to the right of their budget line because they don't have enough money for those options. So that automatically eliminates option B, and that eliminates option D. So given option A and option C, we can see that A has a higher utility because, again, it's on a utility line that is greater than the utility line that C is on. It is also where A is also where the budget line meets the greatest utility line. Okay, so in this case, the satisfaction would be maximized by purchasing 5 tacos if we run our point across, and 2 hamburgers if we are talking about or staying within the budget of $5 per week. This graph reiterates the point that we already showed earlier, that B and D are to the right of the budget line, so they are not going to be affordable for this consumer. This slide reiterates the fact that point C is below the budget line, meaning that the consumer actually can afford to spend more and therefore increase their satisfaction. So this brings us to a practice problem here, and you're actually going to see this problem in your quiz question. So hopefully you're watching this video so that you can get a free answer here. So this says, suppose that Robin budgets $12 a week for wings and suds. The price of buffalo wings is 50 cents, while the price of Coca-Cola is $1.50. So this question asks, which of the following are true? A, the optimal combination of goods for Robin is 12 buffalo wings and 4 of Coca-Cola drinks. B, at point C, the slope of the budget line and the marginal rate of substitution are not equal. C, at point C, the consumer is said to be in equilibrium. Okay, well, we just learned that equilibrium is the point on the graph where the budget line meets the highest utility line. So yes, C is true, that at point C, the consumer is said to be in equilibrium. So that is true. The optimum combination of goods for Robin is 12 buffalo wings and 4 Coca-Cola drinks. That is also true, because when we are in equilibrium, that is synonymous, or that's the same thing as saying that it's the optimal combination. So that would provide the most amount of satisfaction for this consumer, given their budget and given the prices of the items. So A is true as well. And then B says, at point C, the slope of the budget line and the marginal rate of substitution are not equal. If you recall from the previous chapter, the marginal rate of substitution helps us to identify how many wings or how many of one item a consumer is willing to give up to trade for a specific item of another number. And if you also remember the equation for slope, slope is the change in y over the change in x. So the slope of this particular line here, let me clear this out quick. The slope of this particular line here is, we're going change in y, so we're going down 12. So the slope is going to be negative 12 over the change in x. So we're going over 4, positive 4. Okay, so this slope is negative 3. Okay, the marginal rate of substitution in this case is that the consumer would be willing to give up 12 buffalo wings. So give up, we're going to put a negative in front of that, in order to gain 4 Coca-Cola drinks. So if we divide that out, we can see that the marginal rate of substitution is going to be equal to the slope, which tells us that point B is false. So we had a false for B, we had a true for A, we had a true for C. So the answer to this question is going to be both A and C. We have another practice problem here. Suppose that Robin budgets $12 a week for wings and suds. The price of buffalo wings is 50 cents, while the price of Coca-Cola is $1.50. What is the maximum number of buffalo wings that Robin may buy? Okay, so if we look at this, buffalo wings are along the y-axis here, and we know that if he spent all of his $12 on buffalo wings, we just need to divide that $12 by the 50 cents that the wings cost. And anything you're dividing something by a half, you're actually multiplying it by 2. So he could purchase 24 wings. So we can see here that this is 12, halfway up is 12, and if he was buying 0 Cokes on this graph, he would be able to purchase 24 wings, and that's what this chart indicates as well. So the answer to that would be B. I do believe there is a question asking you about the maximum number of Cokes that he could buy. Same thing, if he was buying all Cokes and 0 buffalo wings, you're going to take that $12 and divide it by what the buffalo wings would cost in order to get the number of Coca-Cola that you could purchase. Okay, so this slide is going to allow us to look at consumer equilibrium a little bit algebraically. So this is another way, instead of just looking at the graph for consumer equilibrium, you could look at this equation to determine the consumer equilibrium and to see if, given a situation, you could see if satisfaction is maximized. So consumer equilibrium is achieved when the ratio of the marginal utility of item A divided by its price, whatever that ratio number works out to be, is equal to the ratio found when you divide the marginal utility of item B divided by the price of item B. So if you remember, marginal utility is the amount of satisfaction that a consumer will get from purchasing one more. And we know that the more items we purchase, the lower the marginal utility becomes. So this kind of becomes a balance of the combination of two different items to be able to figure out the consumer equilibrium. Let's look at an example and hopefully it'll get more clear. Okay, so here's a practice problem that you are going to encounter on the quizzes, and that there'll also be a couple more like this. So we'll go through this one together. Assume that for a given consumer, the marginal utility of wine is 100 and the price of wine is $60. Also assume that the marginal utility of lobster is 200 and the price of lobster is 100. This consumer should A, buy more wine, B, is in equilibrium, C, should buy more lobster, or D, insufficient information to give an answer. Okay, so as we saw on the previous slide, the algebraic equation for equilibrium is stated here. So if the marginal utility of item A divided by the price of item A, if the ratio we get after dividing that equals the ratio of the marginal utility of item B divided by the price of item B, we know that we are in equilibrium. Okay, so the first thing that we can do is figure out if we are in equilibrium. And if we aren't, then we can cross off letter B. So let's calculate that out and see. So we have the marginal utility of item A, which is 100. We'll call that the wine. So we have 100 divided by the price of the wine. So 100 divided by 60. Equals the marginal utility of item B. So marginal utility of item B is 200 divided by the price, which is 100. Okay, so let's see what these equal. 100 divided by 60 is 1.67. 200 divided by 100 is 2. Does 1.67 equal 2? No, it does not. So we are not in equilibrium. Those two numbers need to be identical for us to be in equilibrium. Okay, so now we need to figure out how these ratios might change if we consume more wine or if we consume or buy more lobster. Now, if you remember, the marginal utility of a specific product will decrease with the greater amount of that product that you have. For example, if you recall from a previous lecture, if you have 0 hamburgers, the satisfaction or utility that you will get from receiving 1 hamburger will be pretty great. But if you have 2 hamburgers already, or if you have 1 hamburger already, the satisfaction to receive that second hamburger, you still might want another hamburger, but it's not going to be as satisfying as that 0 to 1 change from going from 0 hamburgers to 1 hamburger gut. So on and so forth. If you have 4, 5, 6, 7, 8 hamburgers, if you have 8 hamburgers, getting a 9th hamburger probably isn't going to mean hardly anything to you and isn't going to give you any satisfaction after you've already had 8 hamburgers. In fact, it's probably going to give you less satisfaction. You'll probably get sick if you eat that many hamburgers. So recall here that the more, in this situation, if we buy more wine, the marginal utility of the wine will decrease. The marginal utility decreases with an increase in purchase of a specific product. Similarly, if we buy more lobster, so we're talking about lobster in item B, if we buy more lobster, the marginal utility of the lobster will decrease. If you buy 4, 5, 6, 7 lobsters, the more you buy, the less you want, and the less satisfaction you're going to get from that. So by purchasing more wine, the marginal utility is going to decrease. And what we need to figure out is, if we decrease the marginal utility of purchasing wine, is that going to get us closer to the number 2? Well, let's check that out. Okay, so if we decrease the marginal utility here to, let's just say 90, we'll go down by 10. So if we do 90 and the price stays at 60, 90 divided by 60, I've got to get my calculator out quick. 90 divided by 60 is 1.5. Okay, does 1.5 draw us closer or further away to the number 2? Well, it draws us further away. 1.67 is closer than 1.5, so it drew us further away. So it's not, the answer is not that we should buy more wine. Okay, so we got to move on to looking to see if we should buy more lobster. So again, if we buy more lobster, the marginal utility will decrease. And then we need to figure out, does decreasing the marginal utility of the lobster bring our 2 number closer to 1.67? Because again, when both of these numbers are equal, that is when we are in equilibrium. Okay, so let's just try this here. Let's say we buy more wine, so our utility drops from 200 to, let's just say, 170. Okay, so if it's at 170 and our price still stays at $100, 170 divided by 100 is 1.7. Did buying more wine, which ended up decreasing our marginal utility, bring us closer to that 1.7? Yes, it absolutely did. So we need to, lobster. I'm sorry, we're talking about lobster on this side. Lobster. I need to write that so that I've been saying lobster and wine too much, but we have lobster on this side. So did buying more lobster, which decreased our marginal utility, bring us closer to the 1.67? Yes, it absolutely did. So the answer to this is that we should buy more lobster. Okay, I hope that makes sense. There's a couple more problems out there like that. It's kind of multi-step, and you got to think about the opposite effect. The more you purchase, the lower the marginal utility is going to become, because the less satisfaction you are going to get from consuming more and more and more of a specific product. And then you got to divide that by the price and see what it does to those numbers. Okay, we're going to jump out of algebra for a minute here, and we're going to jump back into graphing. So, reminder from a few slides ago, when we're talking about graphs, consumer equilibrium is going to correspond to the point on the graph at which the consumer maximizes their satisfaction while also staying within their budget constraint. So it is dependent on the price of item A, the price of item B, and the income that the consumer has. So if the price of item A changes, the consumer equilibrium will change. If the price of item B changes, the consumer equilibrium will change. And likewise, if the income of the consumer changes, the consumer equilibrium will change. So if any 3 of these things change, the consumer equilibrium will change. So the point at which they receive the highest satisfaction within their budget, the combination of products purchased, will change. So this is an example to start off with. If we start with the budget line here with an income of $5 and the given prices here, hamburgers are $1.25, tacos are 50 cents, we can see that consumer equilibrium is at point A here, which is 5 tacos and 2 hamburgers. But if the price changes, so as we said before, price of item A can change, price of item B can change, or income can change, and then we're going to have a different equilibrium. So in this case, the price of the hamburger changed. It became cheaper, which means that we could actually, if we were purchasing all hamburgers, we could buy 5 hamburgers. Our income remained the same, so that's going to cause the budget line to shift a bit to the right. It's going to stay in the same place for the tacos because the taco price didn't change. But what this does is it moves us over on some indifference curves, and because hamburgers got cheaper, we are able to become satisfied more at a different point on a higher indifference curve. So you can see that now we're meeting at point B, which is a higher satisfaction than point A, which makes sense. We would, as consumers, be more satisfied if we were able to purchase more hamburgers for a lower price. So that makes sense. Okay, this last graph here, or this third graph here, shows that what if the price increased to $5 of hamburgers? So you would actually only maximum be able to purchase 1 hamburger. Price of tacos still remains the same, and then we can see that our indifference curve that we now line up with is a much lower satisfaction curve, because indifference curve satisfactions increase as we go up and to the right of the graph, and it exists at point C. The highest satisfaction that we can get out of the price of tacos, the price of hamburger, and our budget at this with these numbers would be along C. So you can see as prices change, the equilibrium changes. The highest satisfaction that we can get will change. And also as income changes, the equilibrium can change as well. Okay, so this slide is showing us how we can take the equilibriums, the consumer equilibriums that we gathered from the 3 different prices of hamburgers. So we have points C, A, and B, and we can graph those in a different way to derive or create a consumer demand curve specifically for hamburgers. So consumer demand curves focus on a specific item. So what at a given price, so they tell us at a given price what the demand, what the quantity of demand will be given that price. So we can see at point C here on this with the budget graph over here, at point C, if the price of hamburgers was $5, because if you remember, point C was this first scenario. If the price of hamburgers was $5, then the consumer demand at the high point was going to be 1 hamburger. And we can see point C over here as well. Hamburgers are $5. Demand is 1. Okay? Same thing with point A. So point A was when the hamburgers cost $1.25. So when hamburgers cost $1.25, the amount that was demanded was 2, and we can see that point A appears over here as well on the demand curve for hamburgers. Finally, we can see if the hamburgers were $1. That was our final example over here. Falling on point B, our demand for the burgers is 3. And again, the price is $1. So we can see that B appears over here. Demand is 3, price is $1. So we used the consumer equilibriums to create a consumer demand schedule, which we then just turned into a consumer demand curve. And another name for this curve is called price consumption curve. So it may be referred to with both of those terms, consumer demand curve or price consumption curve. And we're going to spend the next little bit of time in general looking at demand curves. Actually, before we talk about demand curves, we have one more point to make on the effects of income on the change in equilibriums. So here, if, as given in the example before, our income is $5, and the price of hamburger is $1.25, price of tacos is $50, as we saw before, here is the equilibrium at 2 hamburgers and 5 tacos. Now, if we change the income, so the income increases from $5 to $6 per week, our budget line is going to shift up and to the right. It's going to be parallel, but it's going to shift upward to the right. Okay, so there's going to be several practice problems with budget lines shifting as a result to income. So income changes can lead to, income changes do lead to an increased budget, but that doesn't always mean that because your income increases, your consumption of all goods will increase. There are some goods in which if your income increases, your consumption of a specific good may decrease. And that's kind of the difference between normal goods and inferior goods. So normal goods are those goods for which a rise in your income will lead to an increased consumption of that product, and a fall in your income will lead to a decreased consumption in that product. So it might be likely that if you have an increased income, maybe you would go out to eat more, and so maybe your consumption of hamburgers would increase. And that would make the hamburgers a normal good. An example, if we use like ramen noodles for an example, it may be true that if your income increases, you would actually purchase and eat less ramen noodles. So it's not always, so every good can be classified as either a normal good or an inferior good. And we think about the more money you make, if you're going to purchase a good more with an increased income, that would be a normal good. And if you're going to purchase a good less with an increased income, that would be an inferior good. And your budget lines can show what goods you're purchasing more of and what goods you're purchasing less of. As we can see here, both the tacos and the hamburgers increased from budget line 1 to budget line 2, but then to budget line 3, the tacos actually decreased because you can see they went from between 5 and 6 down to 4. So at that income, at the income of $8, the tacos became an inferior good. We can take the equilibrium points from the previous slide and plot them onto this type of graph, which we call an angle curve. So if you recall from the previous slide showed the number of tacos and the number of hamburgers that would be the consumer equilibrium at various income levels, so within various budgets. So if we look at this first graph, this shows us the angle curve for hamburgers based on income. So if the income is $5, the hamburger consumption is 2. If the income increases to $6, the angle or the hamburger consumption is 3. And finally, if the income increases to $8, the consumption of hamburgers is 5. So we can see that the consumption of hamburgers is increasing with an increased income. So that tells us that hamburgers are a normal good throughout all of those budget points. And we have that listed here as a normal good. Now, if we look over the tacos, we see that if the income is at $5, the number of tacos that are at consumer equilibrium are 5. If the income is $6, we do increase. Our equilibrium for tacos is 6. So from the income $5 to $6, we see that tacos follow the trend of a normal good, but then we see, as we saw on the graph on the previous slide, that if the income rises to $8, we actually end up consuming less tacos. We drop down from 6 to 4. So, as stated below here, the tacos are going to be an inferior good as the budget increases from $6 to $8. Okay, now we're going to go ahead and look at an example of how we can use budget constraints and consumer equilibrium to derive or create individual consumer demand curves as well as market demand curves. So with this information, we would be able to predict what the market demand would be at different prices of particular items. So, given this scenario, Betty and Wilma wish to buy t-shirts and shoes. Betty has a budget of $600 while Wilma has a budget of $1,200. Using the indifference curve analyses below, determine prices for the t-shirts and shoes. Okay, that's the first thing that we need to do. Determine prices for the t-shirts and shoes. For which item can you derive a demand curve? Derive the curve for Betty and Wilma. Finally, derive the market demand curve, assuming they are the only customers. Okay, so there's a lot of information, or a lot of things they're asking us here. So let's just start with the first one. Determine prices for the t-shirts and the shoes. Okay, so given these two graphs down here with indifference curves in them, we need to find the price of the t-shirts and the shoes. Okay, if we know that Betty's budget is $600 and we know that Wilma's budget is $1,200. So we know that there are potentially two different prices of t-shirts that we're looking at because we see that there are two different budget lines here. Okay, and it looks as if the maximum number of shoes that could be purchased, if we purchased all shoes and 0 t-shirts, would be 20 shoes. So it looks like the shoe price is not changing. And that's the same over here for Wilma's graph. So if for a specific price, number 1 for t-shirts, if Betty spent all of her money on t-shirts, we can see that she would be able to buy 40 t-shirts at that first price. So if we take $600 and we divide that by 40, we will see that that is 15. Okay, let me double check and just make sure that I did that right. 600 divided by 40 equals 15. Yes. So this first budget line here is showing us that t-shirts have a cost of $15. Okay. Now, if we want to see, so we can start to fill in some of this graph up here. Okay, so we're looking at Betty to begin with. So price of t-shirts, we know for that first line is 15. And the quantity of shirts that she would want to buy at $15, well, we have to look at the consumer equilibrium, which is right here at point A. So if shirts are $40, she would want to purchase 30 shirts and 5 pairs of shoes. So she would be purchasing 30 shirts and 5 pair of shoes because that is what her consumer equilibrium is when t-shirts are $40. Okay, I'm going to erase some of that. So it's getting a little messy there. Okay, so let me rewrite this. So we found the price of the shirts to be $15, the pairs of shoes that she would buy at that $15 would be 5, and the number of t-shirts that she would buy would be 30. Okay, so now we need to find the price of shoes in this situation. So we can see here that if Betty spent all of her money on shoes and no money on t-shirts, that would be $600 divided by 20, and that's going to be 30. So the price of shoes is $30. And we can see that the price of shoes never changes. Okay, so the price of shoes here is going to be $30 as well. Now if we go ahead and look at the second line, the second budget line that I've highlighted in blue, we can see that there has been a change in the price of t-shirts. How do we know that? Well, if she only purchases t-shirts with her $600 budget, the highest number of t-shirts that she can purchase at this point is 20. So in order to figure out the price of t-shirts at this point, we would take 600 divided by 20. 600 divided by 20 is 30, just like the shoes. So this second price of t-shirts is going to be $30, okay? And then along this budget line in which the price of shoes or the price of t-shirts are $30, we can see that the consumer equilibrium is at point B, and she would get the greatest satisfaction at that price point by purchasing 10 t-shirts and 10 shoes. So we can put 10 t-shirts, 10 shoes up there. Okay, so we have all of Betty's figured out at the moment. I'm going to erase some of this. I don't know how to just erase a little bit, but I need some more writing room. Let's see. That's a little bit better. Okay, so this next one that we have is Wilma's to take a look at. So we can see that Wilma would be purchasing 40 pairs of shoes if she only purchased shoes, and she purchased 0 t-shirts. So if we look at her budget is $1,200. So if we took $1,200 and divided that by 40, we will get 30. So we know that, again, the price of shoes is staying consistent and it is not changing, okay? T-shirts, in this case too, we can just double check our work. If she spent all of her money on t-shirts at price point A, we'd do $1,200 divided by 80, and $1,200 divided by 80 is going to be 15. So this is the price. This first line here is where the price of the shirts is $15. So we can write price of t-shirts $15 in there. And then for the second budget line, if she spent all of her $1,200 on t-shirts, she would only be able to buy 40 of them. And to determine that price, we're going to take 1,200 divided by 40, and that's going to give us 30. So we know that the price of shirts for the second budget line is $30, which is the same as the two options that has been given by Betty. So again, if we go ahead and take a look at the consumer equilibrium points here, point C on the $15 budget line, we can see that she would receive the greatest amount of satisfaction by purchasing 60 t-shirts and 10 pairs of shoes. That's at the $15 budget line. So that was 60 shirts, 10 pairs of shoes. And at the $30 budget line, point D is her consumer equilibrium, and she would have the highest satisfaction at 20 pairs of shoes and 20 t-shirts. Okay, so what have we answered so far? So we have, using the indifference curve, determine the prices for t-shirts and shoes. Okay, so we know that shoes are $30, and we have two budget lines that with one representing $15 for the price of t-shirts and one representing $30. So we've answered that. Okay, second question says, for which item can you derive a demand curve? Okay, now demand curves have two pieces of information. They have the price of a particular item on the x-axis, and they have the quantity of that item demanded on the y-axis. So the price of something needs to be changing in order for us to be able to derive a demand curve. So the price of shoes are not changing. So we cannot derive a demand curve for the price of shoes because we cannot see how consumer preferences are changing if the price is staying the same. However, we can absolutely derive a demand curve for the price of t-shirts because we have numbers here that show us the price of t-shirts changing from $15 to $30 to see what that demand might do. Or we see that the demand might change. So what I'm going to do here really quickly is erase, not all of this because I want to keep the numbers, but I'm going to erase some of the work on the bottom so that we can start to, we have all the information that we need to start to derive our demand curves. So if you'll give me just a moment to erase all of this. We'll be doing a demand curve for Betty individually, so that will be called a consumer demand curve. Then we're going to be doing a demand curve for Wilma separately. And then finally, we're going to do a market demand curve that puts both Betty's information and Wilma's information together. I decided to type this up as instead. So we're still looking at the numbers from the previous slide, and we're going to create Betty's consumer demand curve, Wilma's consumer demand curve, and then we're going to assume that Betty and Wilma are the only two consumers in the market for t-shirts and shoes, and then we're going to create the market demand curve. So first curve that we're going to look at here is all of Betty's numbers. Now again, We're not going to do anything with shoes. We're only doing t-shirts, okay? So, because we're just doing the demand curve, the consumer demand curve for t-shirts. So across the top we have the price of, or on the y-axis we have the price, and on the x-axis we have the quantity. So we can go ahead and actually write that on all of these curves, okay? So our price range, if we look at it for t-shirts, is it goes up to $30. So we'll do a 0 here, a 15 here, and a 30 there. Okay, same for Wilma, so we can do the same thing. We have a 0 here, 15 here, and a 30 there. Same for the market, 0 here, 15 in the middle, 30 at the top. Okay, so across the bottom, we're going to have the quantity of shirts that are demanded at each of those price levels. So if we're just looking at Betty at the $15 price level, we see that she demands 30 shirts. So if we're going to graph that, we got to add some numbers down to the bottom. Let's just do these by 10. So we can have a 10, 20, 30, 40, 50, 60. Okay, and I'm not going to write the numbers in here, but 10, 20, 30, 40, 50, 60, 10, 20, 30, 40, 50, 60. Okay, so again, $15 t-shirts, Betty wants 30 of them. So 10, 20, 30 at 15. This point right here, I'm going to do this in a different color. This is the point right here that she would lie at if t-shirts were $15. Okay, now if we have $30 t-shirts, Betty's going to want 10 of those. So if we go up to $30, she's just going to want the 10. So Betty's individual consumer demand curve is going to look something like that. So that's how you would create her demand curve. Now, Wilma's demand curve, if we look at these numbers, so we have the price of t-shirts at 15, she demands 60 if the price is at 15, so 10, 20, 30, 40, 50, 60. So her point would be right there. And then if the shirts are $30, she's going to demand 20 of them. So 10, 20, 30, and right there. So Wilma's demand curve would look something like that. If I could touch the points through there. Okay. And the market demand, what we do with those is we need to add the quantity demanded at each of those price levels all together. So we have at the $15 price level, we have 30 shirts from Betty, and then again, this $15 price level, we have 60 from Wilma. So that would make a total of 90 shirts that are in demand at that level. So we're actually going to have to add some lines here. So we were at 60, 70, 80, 90. So 90 shirts at the $15 price range. And then if we go up to the $30 price range, we have 10 shirts plus Wilma's 20. So that's going to be 30 at the, 10 plus 20 is 30 at the $20. I'm sorry, I have that in the wrong spot. I'm putting the 30 in the wrong spot. So let me just rephrase that really quickly. So at the $30 price range, what I have circled here in red, it's actually going to be 30 shirts as well because 10 plus 20 is 30. So we need to actually move that mark over 10, 20, 30 up to the 30, and then our market demand curve for t-shirts is going to look like that. So you can see how it shifts a little bit when we include both Betty and Wilma's individual consumer demands to make the full market demand curve. This slide cleanly exemplifies the similar concept that we just worked through in the previous few slides. So similar concept here, we're looking at the quantity of hamburgers along the bottom for a specific person, Paula in this case. She demands when the price of hamburgers is $1.50. So she demands 2 hamburgers when the price is $1.50. We have another buyer over here, Beth. She demands 1 hamburger when the price is $1.50. And when we're looking at the market demand, if Beth and Paula are the only consumers in that market, which it would be pretty unlikely that only 2 people were in a market, but as we're learning, we'll imagine that that's the case. So we would take 2 plus 1 to get 3 hamburgers are at the market demand when the price is $1.50. So there are multiple things that can cause a fluctuation or a shift in both consumer demands and market demands. Let's just talk specifically broadly about market demands. So let me make a little graph here just so we can kind of see. When I'm talking about, if I say the market demand curve shifts to the right, what I'm saying, I'm going to put a D here for the demand curve. What I'm saying is that there's been a change in demand and a higher quantity, because remember quantity is along here. A higher quantity is desired at a specific price point. So let's pretend this price point is $100. If there's a shift in the demand curve, it moves to the right in a parallel fashion, and now at that $100 price point, more is actually demanded. So that is what a shift to the right looks like, and that would usually be a good thing for companies to have a shift to the right in the demand of their product, because people are demanding more of their product. Now I'm going to erase that. And if we talk about a shift in demand to the left, again, we have quantity down here, price up here. So we have 0 items being demanded here. Let's say 100 items being demanded here. Again, our price point we'll put at $100. So if we have this as our original demand curve and we say the demand curve shifts to the left, that means people are demanding less at the same price point. So that would not be a good thing for businesses. So there are multiple things that can cause a demand curve to shift to the right for consumers to demand more of it, or to shift to the left for consumers to demand less of it. If the price of the particular product decreases or increases, it is possible that the demand will change. Also, if the price of competitor products decreases or increases, let's think about Nike shoes and Adidas shoes. If all of a sudden there's a big sale on Nike shoes, people are going to demand more of Nike shoes and potentially less of Adidas shoes. So that can cause that to change. If income or wealth changes, people, if they start to make more money, they may end up buying more of a particular item, say shoes or cars or something like that. There's other things that play into consumer demand as well. Advertising. So if let's say KFC did a really incredible advertising campaign and had it all over TVs and billboards, and they had a new product, it's possible that demand for KFC would increase. Health and nutrition, if they tag a specific food, say blueberries or strawberries, as a superfood, the demand for that could increase. Likewise, if they found that a particular food causes a problem, the demand could shift to the left and decrease. If there's a food safety issue, let's say there's a salmonella outbreak in a chicken processing factory, the demand for that product would decrease. So keep in mind what way these demand curves can shift. To the right means that good things are happening for the company and more people are demanding their product. To the left, bad things would be happening to the company and less people would be demanding their product. Okay, the diagram that I just showed you with the shift in the demand curve, so I had the demands like this, and if it shifted to the right, we call that a change in demand. So if the entire demand curve line is shifting parallel to the left or to the right, that's a change in demand. Now, another term here, change in quantity demanded, that's just when a particular person or market moves along the curve up or down. So that's different than a shift, okay, in the demand. So that would just be a distinguishment for you to make, is that movement along a single demand curve is called change in the quantity demanded, and a shift of the entire demand curve is called a change in demand. You can see these graphically represented here. So if people, again, prices on the left, quantity on the bottom. So if we move from point A to point C, meaning that a higher quantity is demanded at the same price, we are going to call that a change in demand, okay? Different than a change in demand is just a decrease in quantity with potentially or an increase in quantity, sorry, with potentially a change in price or something like that. So we have two things that can happen when we're talking about change in quantity demanded is a movement along the same demand curve. So nothing huge from the outside happened. There maybe just was a change in price of the product. Or we can have a change in demand where people are actually, without a change in price, willing to purchase more of an item without a change in price. So again, that could be due to some wonderful advertising campaign that was successful. That can be as a result of a research study that came out and said a specific product was super healthy. People may value that product more and be willing to purchase more at the same price that it was before. The last concept that we're going to look at here in Chapter 4 is the idea of consumer surplus. So consumer surplus can be calculated and figured out by simply utilizing a market demand curve, and it basically demonstrates the difference between the amount of money that consumers were willing to pay for specific items and the amount that they actually paid. So in a sense, a consumer can figure out their advantage that they're getting by purchasing products at a particular price. So we'll look at an example and this will become more clear. Okay, so we're going to use this example, this demand curve, to help us to calculate the consumer surplus for this particular example. But first, let's see what this demand curve is telling us. So the demand curve here, we have the quantity of, let's just pretend we're talking about hamburgers since we've been talking about that all day. Um, so if we're talking about hamburgers, we can say that at the 0 point, we have $11. So this person is not willing at all to pay $11 for a hamburger. However, they will pay $10 for one hamburger. And you can kind of draw that down and see that. They'll pay $9 for two hamburgers. They'll pay $8 for three hamburgers, $7 for four hamburgers, and so on and so forth. Okay? But the beauty is that they are generally, if you go to a restaurant, they're not going to say one hamburger is $10, your second hamburger is $9, your third hamburger is $8. No, they're going to have every hamburger priced exactly the same. So this case, it's showing us that the price of the hamburgers are, well, they give us a $6 example and a $5 example. Let's look at the $6 example first. So in the case that the hamburgers are $6, we see that the consumer is willing to purchase 5 of them. So they purchased 5 hamburgers for $6. They paid a total of $30 for these hamburgers. The consumer was actually willing to pay a little bit more according to this demand curve. The consumer was actually willing to pay $10 for the first hamburger, as we looked at earlier. They were willing to pay $9 for the second hamburger, $8 for the third hamburger, $7 for the fourth hamburger, and $6 for the fifth hamburger. So the consumer, if they bought all of those hamburgers at the price that they were willing to pay for each of those, if we add that up, 10 plus 9 plus 8 plus 7 plus 6, the consumer was actually willing to pay $40 for 5 hamburgers, but they only had to pay $30 because the restaurant prices all the hamburgers the same. So in this case, they were willing to pay $40. They only had to pay $30. So the consumer surplus is approximately $10. Now, it's actually going to be a little bit more than that because what we did not take into account is how much they were willing to pay for 9.5 hamburgers or 8.5 hamburgers or 7.5 hamburgers. So the best way to find the true consumer surplus is to figure out the area of the demand curve above the price point. Okay, so in this case, the area above that, we just need to take the base times the height divided by 2. So going across here, our base is 1, 2, 3, 4, 5, 5 across, and 1, 2, 3, 4, 5 up top. So 5 times 5 is 25, and if we divide it by 2, we're going to get 12.5. So the consumer surplus in this example is $12.50, which is close to that $10. Okay, but again, it's going to be a little bit more because we had some half numbers and things that we hadn't accounted for. Okay, I'm going to erase all of this, and we're going to look at what would the consumer surplus, or by how much would the consumer surplus change if we decrease the price of hamburgers from $5 or from $6 to $5. So we would increase the consumer surplus by the additional area that we add to the triangle above this new price point, which is the gray shaded area. So if we lower the price from $6 to $5, our additional consumer surplus is going to be the area of that gray shaded area. So how we're going to do that, first we'll find the area of this rectangle, and then we'll find the area of the small triangle. So going across here, we have 5 units times 1 unit. So that's going to be 5. So that's our first surplus, which is $5. And then we have 1 unit times 1 unit for the triangle. Here, I'll change my color. 1 unit up and down, 1 unit across, divided by 2. So 1 times 1 equals 1, divided by 2 is going to be 50 cents. So we're going to add 50 cents to our $5, and our additional consumer surplus is $5.50. Now, so this is $5.50. Above it, we had $12.50. So our total consumer surplus at that $5 $5 price point is $12.50 plus $5.50, which is $18. Okay, so there'll be a few questions regarding the consumer surplus in your quizzes for this week. I think I've given you enough information to chew on. Again, I probably didn't go through every single concept, but if you have specific questions for me, you can always email me, and any general questions that you think might apply to the entire class, you can always post on the discussion board that is online. Thank you.